Hello, welcome to this video. Today we're going to be talking about a little bit about inferential statistics and the way that we can use the different tools to be able to take data from a sample and be able to generalize for a whole population. So I'm going to be using this made up example of different students who had different sort of methods of studying by using background music. We have rock music, we have classic music, and we have a group that studied in silence. And what we're going to be doing is we're going to be using two different tests to be able to analyze this data. All right. So remember, there's a difference between descriptive statistics, which is your average, your median, your mode. All of that information is kind of describing the data that you already have. And what we're trying to do here is we're trying to take our data and trying to generalize or conclude for a population instead of just the sample that we have. All right. So for me to be able to do this, we have to talk about a couple of concepts. So the very first concept is the t-test. The t-test is going to be the first tool that we use. Now, in our t-test, we have different types, okay? We have paired, and we're gonna call it unpaired. We're gonna automatically just go with these two types. The unpaired is going to eventually be separated into two, but we'll talk about that a little bit later. Now, a paired t-test is when you have one group with two variables, okay? An unpaired t-test is when you have two groups with one variable, okay? So using this example right here, in our t-test, we're just going to be comparing two things, whether it is two groups or two variables. In this case, we're going to be comparing our rock music group to our silence group. We're going to leave the classic music for the next test that we do. But for now, we're going to focus on these two right here. I'm going to highlight them for you. Give me just a second. Here we go. Okay, so we're going to focus on those two groups to be able to compare them a little bit. And in this particular case, like we said at the beginning, these are different people that studied with different methods, okay? Therefore, in this case, we have the exam grades, which is our variable that we're testing out, with two different groups. It would be completely different if I said that we have one group of people and that group of people tries different study methods. Okay? That's a completely different experiment. It sounds very similar, but think about it that way. We can have one group with two different variables or two groups with one variable. Okay? So in this particular case, we have two different groups with one variable. So we have an unpaired t-test. Okay? So the way that we're going to answer this is the following. I'm gonna use my Excel tools. I'm gonna go to data, and all the way to the right, I should have this button. This button is super important for these tests. If you don't have this button, we need to access it. In PC, it's super easy. We go to File, Options, Add-ins, and then from the add-ins, we're gonna go to Go, okay? In Mac, it's all the way at the top. It says Tools. And we're going to go to same thing, add-ins, and it's going to give you a few options. One of those options is this data analysis, all right? So I'm going to go to data analysis, and it's going to give me a few different options for my data analysis, and I'm going to look for my t-test. Now notice how there's three different types. We have our paired and we have our unpaired Okay? Like I said before, the unpaired is going to be separated into two. Now, the difference between the two is we have equal variances or unequal variances. In our case, we're always going to assume unequal variances. This is the most common thing to do if we don't know the variances themselves. Okay? So it's either paired or unpaired or two sample with unequal variances. So first or third. Okay? In this case, we said we were going to go with unpaired. So, okay? Now I'm going to select my two ranges. So information here for my first group, information here for my second group. Okay? Now, this thing right here, my alpha, it's important. I'm going to leave it at 0.05. What this means, and we're going to talk about that a little bit later on as well, is we want the end tails of our whole data. Okay? So what happens here is we're trying to identify whether our null hypothesis is accepted or alternative hypothesis is accepted, and we'll talk about that in a second as well. Okay? So I'm gonna click OK. And right here, I have these two sets of data right here. These are the most important ones. So, like I said, we're trying to make this sort of bell curve. And in our bell curve, imagine we have all of our data. And from all of our data, I want to know if the difference between my averages goes inside of the percentage that is to the endings. So in other words, and let's say it in a little bit of simpler words, I'm trying to identify whether the difference between my averages is really, really common or really, really rare. If it's really, really common, then that means that I'm accepting my null hypothesis. Okay? What that means, it's you're inside of the normal data. It could happen randomly, whatever. Okay? If this is not common, then what we're accepting is your alternative hypothesis. Now, the common thing is for my p-value to be greater than my alpha. Okay? The not common thing is for my p-value to be less than my alpha. Okay? And what this means is if I'm in this option right here, I'm going to put it in a blue color. If I'm in this option right here, it means that the difference between my two averages, let's say here we have 87 and 80, the difference between them is not significant. Okay? If I'm in my alternative hypothesis, let's put it in a different color. Let's put it in green. If I'm in my alternative hypothesis, then so in general terms, our null hypothesis says that there is no significant difference. Our alternative hypothesis says that there is significant difference. What that means is that if we fall into this blue category, then we can't really say that the difference between the averages is enough for me to be able to say that rock music and silence are going to be different enough. The results on my grades are going to be different enough. Okay? If my alternative hypothesis comes in, then I can say that there is a difference between them. Now, the difference between these two right here, in the one tail, what it's looking for is whether one is bigger than the other. Okay? So it's just taking one end of our information just to see whether our data is our rock music data or our silent music data is bigger than the other one. In the two tails, we're just looking for trying to see whether they're different. So usually the most common thing is for us to go with the two tails. Okay, so always with the two tails just to see if they are different from each other. Okay, that's a common thing to do when we're starting off. All right, so in this case, our p-value is less. Therefore, we can say that there is a difference between the two grades that we're getting. Okay, so that's a t-test. Now, the ANOVA. The ANOVA test, we're only going to focus on one type of ANOVA in this particular video, which is the single factor ANOVA. What this means is that there's only one thing that we're changing in general terms. Okay? So, in general terms, we're only changing the music. Okay? If we change other things, it becomes a much more complex experiment. So we're going to go with this. Now, the difference between the t-test and the ANOVA is that in the ANOVA, we have different groups. We have more than two groups. In the t-test, we only have two. Therefore, for my ANOVA, I'm going to take all of my groups and I'm going to unhighlight them just so you can see. Okay? The ANOVA, super easy. We're going to go to data again, data analysis. And I'm going to go all the way at the top where it's a single factor and click OK. Now notice how here it doesn't ask me for different columns or different groups. It's asking me for the whole range. Therefore, I'm going to select my whole range and it's asking me how it's grouped. In this case, we have it grouped by different columns. If we had all of the grades in different rows, then we would click on rows. But usually we have it in columns. It's not so common that we have it in rows. Okay? Be careful with this button right here with the labels. Just in case, just don't select the labels. That's my suggestion. And the alpha is going to stay the same. So we're going to click OK. And the p-value is this one right here. Now this number right here, I'm glad it popped up. This value right here, it has an E on it. This E means times 10 to the negative 8th power in this case. Therefore, I'm going to copy this same rule that's right here. I'm going to put it over here just so I have it in hand. Okay, so right here. And my value is 1.6 times 10 to negative 8. Therefore, I am also in my alternative hypothesis, which means that there is a difference between the averages. There is a statistically significant difference between my averages. So I can say that there is a difference, or I can conclude that there is a difference between using different types of music or having silence. Now, there's a lot of different ways that you can analyze this data right here, but these are just two ways. All right. So I hope this video helped out to be able to identify the two tests, the t-test and the ANOVA, and I'll see you on the next video. Bye. Have a nice day.